At this point in history, adults need to help young people to become climate literate for political purposes. They must protect their young and the unborn from political and moral corruption. The International Panel on Climate Change makes useful information toward this end available online. This channel will make some of these documents available in the following format as well as other means of presentation as work progresses. This document promises some valuable information for those new to climate change and climate science. Do not expect to comprehend it on the first reading fully. Return often and find that it becomes a bit easier with each read. The information here is quite shocking, considering that so many people call the IPCC conservative. Find the internet address for this document in the below description window. I edited the following robotic reading of the Intergovernmental Panel on Climate Change, IPCC. My edit sought to remove unnecessary navigation aids in the document for reading. Otherwise, the material remains fairly consisting of the original IPCC document. Also, the terms very high confidence, medium confidence and other confidence ratings appear as indications of the conclusions of the IPCC. Quoting about 90% of the original document herein out. All people on Earth depend directly or indirectly on the ocean and cryosphere. The global ocean covers 71% of the Earth's surface and contains about 97% of the Earth's water. The cryosphere refers to frozen components of the Earth system. Around 10% of Earth's land area is covered by glaciers or ice sheets. The ocean and cryosphere support unique habitats, and are interconnected with other components of the climate system through global exchange of water, energy, and carbon. The projected responses of the ocean and cryosphere to past and current human-induced greenhouse gas emissions and ongoing global warming include climate feedbacks, changes over decades to millennia that cannot be avoided, thresholds of abrupt change, and irreversibility. Human communities in close connection with coastal environments, small islands, including small island developing states, polar areas, and high mountains are particularly exposed to ocean and cryosphere change, such as sea level rise, extreme sea level and shrinking cryosphere. Other communities further from the coast are also exposed to changes in the ocean, such as through extreme weather events. Today, around 1 million people live permanently in the Arctic region, of whom 10% are indigenous. The low-lying coastal zone is currently home to around 680 million people, nearly 10% of the 2010 global population, projected to reach more than 1 billion by 2050. Small island developing nations are home to 65 million people. Around 670 million people, nearly 10% of the 2010 global population, including indigenous peoples, live in high mountain regions in all continents except Antarctica. In high mountain regions, population is projected to reach between 740 and 840 million by 2050, about 8.4 to 8.7% of the projected global population. In addition to their role within the climate system, such as the uptake and redistribution of natural and anthropogenic carbon dioxide, CO2, and heat, as well as ecosystem support, services provided to people by the ocean and/or cryosphere include food and water supply, renewable energy, and benefits for health and well-being, cultural values, tourism, trade, and transport. The state of the ocean and cryosphere interacts with each aspect of sustainability reflected in the United Nations Sustainable Development Goals. Over the last decades, global warming has led to widespread shrinking of the cryosphere, with mass loss from ice sheets and glaciers, very high confidence, reductions in snow cover, high confidence, and Arctic sea ice extent and thickness, very high confidence, and increased permafrost temperature, very high confidence. Ice sheets and glaciers worldwide have lost mass, very high confidence. Between 2006 and 2015, the Greenland ice sheet lost ice mass at an average rate of 278.11 gigatons per year, mostly due to surface melting, high confidence. In 2006 to 2015, the Antarctic ice sheet lost mass at an average rate of 155 gigatons per year, mostly due to rapid thinning and retreat of major outlet glaciers draining the West Antarctic ice sheet, very high confidence. Glaciers worldwide outside Greenland and Antarctica lost mass at an average rate of 220 plus or minus 30 gigatons per year. Arctic June snow cover extent on land declined by 13.4 plus or minus 5.4% per decade from 1967 to 2018, a total loss of approximately 2.5 million square kilometers, predominantly due to surface air temperature increase, high confidence. In nearly all high mountain areas, the depth, extent, and duration of snow cover have declined over recent decades, especially at lower elevation, high confidence. Permafrost temperatures have increased to record high levels, 1980s present, very high confidence, including the recent increase by 0.29 degrees Celsius plus or minus 0.12 degrees Celsius from 2007 to 2016 averaged across polar and high mountain regions globally. Arctic and boreal permafrost contain 1460 to 1600 gigatons organic carbon, almost twice the carbon in the atmosphere, medium confidence. There is medium evidence with low agreement whether northern permafrost regions are currently releasing additional net methane and CO2 due to thaw. Permafrost thaw and glacier retreat have decreased the stability of high mountain slopes, high confidence. Between 1979 and 2018, Arctic sea ice extent has very likely decreased for all months of the year. September sea ice reductions are very likely 12.8 plus or minus 2.3% per decade. These sea ice changes in September are likely unprecedented for at least 1,000 years. Arctic sea ice has thinned, concurrent with the transition to younger ice, between 1979 and 2018, Arctic sea ice extent has very likely decreased for all months of the year. September sea ice reductions are very likely 12.8 plus or minus 2.3% per decade. These sea ice changes in September are likely unprecedented for at least 1,000 years. Arctic sea ice has thinned, concurrent with the transition to younger ice, between 1979 and 2018, the areal proportion of multi-year ice at least 5 years old has declined by approximately 90%, very high confidence. Feedbacks from the loss of summer sea ice and spring snow cover on land have contributed to amplified warming in the Arctic, high confidence, where surface air temperature likely increased by more than double the global average over the last 2 decades. Changes in Arctic sea ice have the potential to influence mid-latitude weather, medium confidence, but there is low confidence in the detection of this influence for specific weather types. Antarctic sea ice extent overall has had no statistically significant trend, 1979 to 2018, due to contrasting regional signals and large interannual variability, high confidence. It is virtually certain that the global ocean has warmed unabated since 1970 and has taken up more than 90% of the excess heat in the climate system, high confidence. Since 1993, the rate of ocean warming has more than doubled, likely. Marine heat waves have very likely doubled in frequency since 1982 and are increasing in intensity, very high confidence. By absorbing more CO2, the ocean has undergone increasing surface acidification, virtually certain. A loss of oxygen has occurred from the surface to 1,000 meters, 3,000 feet, or about 5 miles deep, medium confidence. Globally, marine heat-related events have increased. Marine heat waves, defined when the daily sea surface temperature exceeds the local 99th percentile over the period 1982 to 2016, have doubled in frequency and have become longer lasting, more intense, and more extensive, very likely. It is very likely that between 84 to 90% of marine heat waves that occurred between 2006 and 2015 are attributable to the anthropogenic temperature increase. The ocean has taken up between 20 to 30%, very likely, of total anthropogenic CO2 emissions since the 1980s, causing further ocean acidification. Open ocean surface pH has declined by a very likely range of 0.017 to 0.027 pH units per decade since the late 1980s, with the decline in surface ocean pH very likely to have already emerged from background natural variability for more than 95% of the ocean surface area. A drop in pH means more acidic. A rise in pH means more alkaline. The global ocean grows more acidic, then. Global mean sea level is rising, with acceleration in recent decades due to increasing rates of ice loss from the Greenland and Antarctic ice sheets, very high confidence, as well as continued glacier mass loss and ocean thermal expansion. Increases in tropical cyclone winds and rainfall, and increases in extreme waves, combined with relative sea level rise, exacerbate extreme sea level events and coastal hazards, high confidence. Unquote.